Okay, so we've all been there, right? You type a question into a chat box, hit enter, and boom. What comes back feels like pure magic. But have you ever really stopped and wondered what's going on behind that blinking cursor? Well, that's what we're going to do today. We're going to pull back the curtain and demystify how these large language models really work. I mean, what are you actually talking to? Is it some kind of superbrain? A giant futuristic encyclopedia? The truth is, it's something else entirely. We're going to break it down and give you a much better mental model for what's happening inside that box. So, it all kicks off with this first huge phase called pre-training. This is where the model goes from a blank slate to something that understands the fundamental rules and rhythms of human language, all by consuming an unbelievable amount of text. This whole pre-training thing really boils down to four main steps. First, you basically hoover up a massive chunk of the public internet. We're talking everything from web pages to books to code. Then you do your best to clean it up, then filter for the good stuff. After that, it all gets chopped up into these little pieces called tokens. And finally, you get to the main event, training a giant neural network on one deceptively simple task. And when I say massive, I mean it's hard to even wrap your head around. A pretty typical dataset, even after being heavily filtered for quality, can still be around 44 terabytes of pure text. Just imagine a single giant hard drive absolutely crammed with the distilled knowledge, culture, and yeah, all the noise of the internet. Now, this is absolutely crucial. The model doesn't see words or letters the way we do. It sees tokens. The best way to think about them is like the atoms of language. They're just common chunks of characters. And this process, tokenization, is fundamental to everything that follows. And look at this. It's a perfect example of what's happening under the hood. To the model, the phrase, "Hello world," isn't text. It's just a sequence of numbers, basically unique ID codes for each token. That entire 44 terabyte dataset that's converted into a gigantic, sprawling sequence of these numbers. So you've got trillions of these tokens. What's the point? Well, during this entire pre-training phase, the model has one and only one objective. Look at a sequence of tokens and just predict which one is most likely to come next. That's it. That's the entire game. I absolutely love this analogy from Andrej Karpathy. The model has billions of internal settings, or parameters. Training is just the process of twisting these billions of knobs over and over, trying to find the one perfect setting that can reproduce the music, the statistical patterns of human language it saw in its training data. After months and months of this process, what you end up with is called a base model. But, and this is a huge but, this is not ChatGPT. A base model is more like a powerful internet simulator. It's incredible at completing text patterns, but it's not a helpful assistant. It can't follow instructions or answer questions. It just completes what it's given, like a weird digital dream. Okay, so how do we go from this wild, untamed internet simulator to the helpful, conversational partner that we actually want to talk to? Well, that brings us to the second major stage, fine-tuning. This time around, the process is way more focused and much smaller. You have actual humans writing out thousands of high-quality, ideal conversations. Think of a question followed by the perfect, helpful answer. The base model then continues its training, but only on this new, refined dataset. It's essentially learning the persona of a helpful, truthful, and harmless assistant. So let this sink in for a second, because it's a really important mental shift. When you're chatting with an LLM, you're not talking to a magical, conscious being. You are interacting with a highly advanced statistical model that is simply simulating the patterns of the human writers who showed it how to be a helpful assistant. Right, so now that we know how they're built, we can start to really understand why they act the way they do, both the brilliant parts and the really weird parts. Let's dig into the psychology of an LLM. Okay, if you remember just one thing from this whole explainer, make it this. For every single token a model generates, it performs a small, fixed amount of computation. This means they need to write things out, token by token, to have the computational space to actually solve a problem. They can't just jump to the final answer. They need tokens to think. And this right here is the perfect illustration of that idea. On the left, when you ask for just the final answer, you're forcing the model to try and solve the problem with very few tokens, which is kind of like doing complex math in your head. It's easy to make a mistake. But on the right, when you ask it to show your work, you're giving it space, lots of tokens, to lay out the problem step by step, which makes getting the right answer way more likely. So just burn this into your brain. Every token is a thinking step. Forcing a short answer is like asking someone to solve a tricky problem in 1 second. Giving it space to reason is like letting them grab a pencil and paper to work it out. All right, but what about the elephant in the room? Why do these things sometimes just make stuff up? What's going on with these so-called hallucinations? Well, it's actually a totally logical, if pretty annoying, side effect of its training. Remember, it was fine-tuned to imitate the style of a helpful, confident assistant. So when it doesn't actually know a fact, it doesn't say, "I don't know." Instead, its programming kicks in to produce text that looks and sounds like a correct answer, because that's the most statistically likely pattern. It's essentially guessing the format, not retrieving a fact. Okay, so with all of this new insight, how can we actually get better at using these tools? It really all comes down to having the right mental model for how an LLM actually knows anything. The easiest way to think about this is that the model has two kinds of memory. Its parameters, those billions of knobs, are like a vague, long-term recollection of the internet. It's hazy, prone to errors, kind of like you try and remember something from 10 years ago. But the context window, the stuff you actually type into your prompt, that is its perfect, crystal clear working memory. It's right there, and it's totally reliable. And that leads to the single biggest pro tip for getting better results. Stop making the model recall information from its fuzzy memory. Whenever you can, just give it the information it needs directly in the prompt. Don't ask it to summarize a chapter from a book it might have read. Copy and paste the chapter in and say, "Summarize this text." All right, let's tie this all together. First, an LLM isn't a brain. At its core, it's a next token predictor. Second, it was built in 2 stages. Trained on the wild internet, then fine-tuned to be helpful with human conversations. Third, to solve complex problems, it needs to think out loud by generating step-by-step reasoning. And finally, always remember that its working memory, your prompt, is way more reliable than its long-term memory. So now you've peeked behind the curtain. You've seen how it's built, how it thinks, and why it acts the way it does. You have the mental model to unlock its true potential. The only real question left is, knowing what you know now, how are you going to use it differently?